So several things. Last section went a little rough. So I want to have some ground rules here. It's really important when we go through the demo in this class that you follow each step and that you're vocal if you get an error message or get stuck. What's happened is that I found out 10 minutes later that a large portion of the class was way behind, and there was nothing I could do about it at that point. So I need you to try to keep up. I will walk around and make sure that people are following along. But if you're on, TikTok or on some other site while we're doing the demo, there's nothing I can really do to help you. So if you're honestly trying and you're running into errors, let me know, and we will come by and help you. Or Janik will once he gets here, and we will help you as best we can in order to, if there's any issues. But it's very, very important to follow the correct directions here because everything builds off of everything else. I had a couple students who cannot get into their EC2 instance anymore because they had a syntax error in their Bash RC file. So it's very, very important that we get that right. So it's a learning experience. This whole class has been a learning experience. And one thing that I've learned is that we need to probably do this differently next year. I think we need to probably move the Unix fundamental stuff earlier, either at the beginning of 402 or as a workshop that runs parallel to it or before 402 starts. That's really, really important. You may use Windows or Mac in your careers, but it's really important to understand how to work with a Unix system. And we did learn it, but I'm seeing that for a lot of people just didn't absorb it, which is really, really unfortunate. So we need to do something about that. It's something I've been thinking about for quite a while. And I'll talk a little bit about the project before we start with the lecture slides. There's actually not that many slides today. It's mostly demo-based and answering questions about the project. So what else about that? Oh, I've had to make some changes to the project requirements because the AWS free tier is extremely limiting. It's extremely limiting. You saw that when you tried to run Neo4j and you accidentally ran something else with it and your whole instance crashed. We cannot do a data management or data science class with 1 gigabyte of RAM. That's all the free tier gives us. So either I want to apply for a grant so that you can do more cloud computing, or there's a group, some of them may be in this class, but the guy was in my other class, Sandor, was saying that his group is using Google Cloud instead. And so they're using the Google Cloud suite of products based on something else that he has. But I do have credits for Google Cloud, $50 coupons. If your group would like to use Google Cloud and you're up for that challenge, quite frankly, it's a little bit, I think it's easier to use in terms of limitations than AWS is. You can request those from me and I'll give them to you. This way you can run whatever kind of instance you want. You'll go through your $50 quicker, but you're not limited to just using this 1 gigabyte trash. You can use bigger instances. You can also use the other services like their MapReduce product. You can't do that on AWS. You're not allowed to use EMR. You're also only allowed like a gigabyte on S3, which is ridiculous for this type of class. So Google Cloud just offers more there. And so if you want to do that, I can give you coupons for that. I did make one big change out to the spec that should make people happy. Your exam is visible. It's been so long since then, it feels like. It should be visible now. If it's nagging you about needing to use Gradescope, I suggest just using Gradescope to view it. It shouldn't do that because I disabled it, but it might be stuck. It might be stuck. So just use Gradescope to view your exam if you have to. That way we can, move on or review it and answer questions. Let's see. Overall, the grades were a lot better than I was expecting, so that's good. It's just the performance on some of the questions was surprising. So like the LS one, the Unix commands ones were disappointing. The DuckDB ones were disappointing because there wasn't anything trick there. You converted the from statement to a select star from. That was it. And what was the other one? Oh, and it was a group by. All you did was write a basic SQL query. There's nothing DuckDB specific about it. So some of them were a little disappointing, but overall it was pretty decent. The regular expressions, I was expecting that was actually pretty good. I was expecting that to be pretty bad, and it wasn't. It was better than I expected, so that's good, but no more exams. So that's, a good thing. Your final is the final project, obviously. So we talked about the exam. Homework 4 is posted. Homework 4, you're writing a MapReduce job in Colab. So instead of having you install, you can actually run it on your EC2 instance if you want. I prefer if you use Colab because that's a standardized environment for this project. So the Colab, I've given you, this is a similar project to what my CS students do, but I've given you some of the utility code already to avoid that. It's like a leak code problem. So all you're doing is basically the data manipulation part. And if you follow the directions in the Colab, you can copy and paste your final code, run a cell, and it will download a zip file containing your code. You then take that zip file and submit it to Gradescope, and it runs an auto grader. So there's no manual grading on this. It runs it, and it auto grades it and checks the correct answer. So you can keep submitting until you get 100, basically. Or if you don't want 100, you want 50, you keep resubmitting until you get 50. Whatever, you know what your score is, and you can keep working towards 100. And there's no hidden test cases. We sometimes manually adjust scores down only if there's like some shenanigans, which does happen every once in a while with the security students. So, but I don't think I'll have to do that. So that's due. I don't remember when that's due, but it's posted, and it'll help you with the project as well. Okay, the project. There's been a lot of questions about the data. I realize I need to go back and modify the spec just to clear this up. I mentioned not using rectangular data, and I mentioned avoiding using Kaggle data. I shouldn't have said that. What I meant was, do not download a very simple pre-processed data set that is designed for a very specific use case. So for example, that stupid Titanic data set, like predicting who dies on the Titanic or whatever, that data set was created for that use case. There's nothing you can do with it other than analyze to build a model, a logistic regression model. A lot of the data sets on Kaggle, though, are large enough that you can do a variety of things with them, aside from whatever competition they were used for. So that's okay, as long as you have to pre-process the data in order to suit your project and your use case. It's okay to use data from Kaggle. It just can't be pre-processed. And then, you may want to look at multiple different disparate data sets. Now, what I want to comment on that is it's possible that the data set that you pick is within a very large realm of data sets. It's okay then to stick within that same realm. So for example, if we were here at UCLA, if I'm doing a data science project and I work for the registrar's office or something, I have access to grades on one screen and in one database, and I have access to enrollment in another screen or another database. That's very interesting data to join together. It's still a similar use case, but it's very different data. So that's okay. So if you're working like with the PEMS data from Caltrans, there's multiple different data sets that you can work with within PEMS. That's what we did in week 2. And that's okay. We just don't want you to use like, I'm gonna give you an example of New York City taxi data. And I don't want you to use the taxi data as one data set and then the mapping of location ID to a particular borough of New York City as your other data set. That's stupid. That's not showing anything, basically. It's showing that you can write a join, which I hope you know how to do at this point. So that's what I mean by disparate data sets, and the wording will get more precise as this class gets offered more and more. The proposal is due tonight. It should be in a Google Doc. I apologize for not saying that sooner. So if it's in a Word document, just copy it over. I can't read Word anyway. On Gradescope, you will submit the link to that Google Doc, so make sure that it is shared with either anybody who has the link or UCLA Google Apps, and make sure it has comment permission turned on. That's how we're going to provide you feedback on your project. So submit what you have. If we don't like it or we think you need to add another data set, we'll let you know. We'll help you look for one as well, especially if it's from Kaggle. There's a ton of great data sets there. And there's a lot, online too. There's a Reddit data. There's this guy. Well, it's no longer a guy, but he created a startup called PushShift, where he collects a lot of. So there's a subreddit for him where he collects a lot of social media data. So he used to collect a lot of every Reddit comment and every Reddit post ever posted on Reddit for like the past 15 years or something that you could download and use and whatnot. So he has there's some TikTok data. He's got a lot of data there. There's another site called, it's a mailing list, but it's called Data is Plural. That also often has really interesting data sets. What's nice about Kaggle though is oftentimes companies will provide data. So typically you can't get information from companies. You can't get data from companies. But they enter into all these legal agreements with people that work at Kaggle, and they post some of their data. So it can actually be very, very interesting. There's bike share data, there's taxi and Uber data, all kinds of, or you can scrape your own data. So there's some groups that are doing that. They're collecting stock data from some API and writing it to a file and analyzing that. You can do that as well. The possibilities here are really endless. So that's the data for the project. Are there any other questions about the project and the logistics of it? So the proposal is due tonight. The proposal includes the proposal itself, but also filling out the form specifying who's in your group. You need to create a GitHub account and give us the username so that we can invite you to the class GitHub organization. We're not going to complain if you use your own private GitHub. The problem is we're not going to be able to provide support because we don't have admin access to your private accounts. So we prefer that you use the class organization GitHub. Any other questions? The iClicker is open, so do that. I have a quiz that I want to give you, sort of. It's a multiple choice quiz that has no question here, basically. Mark A if you already have your data set. Mark B if you do not have your data set yet. So 3 people didn't vote. That's okay. So 91% of you have found some kind of data set. Good. The other 4 of you need to get a step in here. All right. If there are no other questions about that, I will move on to the slides. But there's actually not that many slides this lecture because we're mostly doing demos. This should help you with the main deliverable for this project, which is a pipeline. Basically, you're developing a pipeline that starts with data and ends with aggregates in DuckDB or some other data warehouse. Then you're going to have a visualization tool that sits on top of DuckDB or whatever data warehouse you're using that uses those aggregates to display data. The reason why we need aggregates and a data warehouse is because this visualization needs to be snappy. If we click on something, it should repopulate quickly. And if you use a data warehouse for that, that's what's going to happen. If you use OLTP, a relational database system, stuff is going to be very, very slow. Or if you use Spark under the hood, it's going to be very slow as well. All right, so final project, some changes I've made. Then I'll talk about, we spent most of the time on number 2 here, which is a data pipeline demo. What is a pipeline? It's one of the course outcomes for this class. One thing that I'm trying to figure out is we're all trying to figure out, though I need to lead it, is what we want the future of the class to be. Historically, this has basically been a data engineering class. So, it was a lot of OLAP, it was a lot of Bash scripting, it was a lot of learning Unix commands, more than what we even covered. And that's great and all, but it's very dry. It's not incredibly modern. So I think I may have overshot here with being too technical, but we need to figure out, is this a data management class where you learn how to manage data? Or what do we mean by data management? There's a variety of different definitions, and the registrar description just doesn't help at all here. So I try to use what our previous instructor did, and we need to make some changes. So the final project. Again, the final project required, in the preterite tense, 5 gigabytes. The problem here is that you're working with an EC2 instance that only has 1 gigabyte of RAM. So when I tried loading my sample data set, which is only about a gig, it crashed my entire instance. And I can't have that happening to you every 5 minutes on this project. It would be extremely frustrating. So there are ways around the limitations with using 1 gigabyte. If you're technically sophisticated, you can research these and you may actually be able to make it work on your EC2 instance, but I don't expect the average student is going to be able to do that. So because of that, I'm going to drop the 5 gigabyte requirement. Instead, you should look for data that's a couple hundred megabytes. Basically, when you load it into Spark, you're going to get a lot of overhead that is going to go beyond 1 gigabyte. It's not just based on the data. So if you've already found your 5 gigabyte data set and you're doing well, you're running Spark and you're not having a problem, continue doing that. If you did download, you did get 5 gigabyte data set, I'm going to assume it's for a year's worth of data or something. Just split it into months and process, either 1 month at a time or just work with 1 month of data. That will make this much easier for you. You're still going to have to do stuff in Spark and you're still going to have to do stuff in a data warehouse. So we're not learning much we're not losing much of the pedagogical goal here. Yeah, so just subset it if need be, but try it. So for example, the group that's using Google Cloud, they have a very large data set, and they're doing their thing and they don't seem to have any issues, but they are using Google Cloud, which is not as limiting. So again, if you want to take on that challenge, I can provide you coupons for that. Every student gets a coupon, and basically your whole group can create one instance. Like I was saying, you create a user account, everybody logs in. In this case, you create one instance, and you all share it, basically. What happens when when one student runs out of money? Nobody gets billed. It just shuts down. So we don't have to worry about people getting billed either. So then when you'll get a warning from Google that you're running low on funds, then what do? You just switch the billing account to student 2's coupon. And when you run low on that, you switch to student 3's coupon, and so on and so forth. Nobody gets billed. It's very easy. You can have a lot of fun with this project and really explore a lot. So we can make that pivot if you haven't started yet, and just let me know. Okay, so due tonight is the project proposal, and fill out the Google form. Make sure you give us comment access. That's how we're going to give you feedback. If you have not yet found a group, you need to find a group today. You need to find a group today. It's just simply not submitting the project, saying that it's only 30%, isn't an option. For policy reasons, the final project is the final deliverable. If you don't submit a final project, you fail the class, just automatically. That's a policy. That way, if there's a medical reason, you can drop it after the course ends. There's a variety of reasons, but we have to give you an F if you don't submit the final deliverable for the class, even if your grade doesn't calculate out to be an F. So find a group and submit the project. We can try to help you. If anybody has space in their group, if anybody needs more people in their group, post on Piazza and see if we can recruit anybody who does not have a group. Is there anybody here that does not have a group and that doesn't mind raising their hand? Doesn't look like it, but if you are, let us know. Okay, in Lecture 7, we provided a couple of helpful hints. One is, I don't know how the previous offerings of this class did this, but you all have to work on the same data and the same code. So my suggestion here is pick somebody's instance to use as the master instance. Back up your code frequently, meaning commit it to GitHub frequently. What might happen is somebody's instance might crash. Well, now you have 5 other people in your group. You can use their instance instead. All right. So what you want to do is create multiple user accounts, or actually, I take that back. You want to create one user account for your group, username and password. Everybody in the group shares that username and password. Don't give it to anybody else. And then you basically act like you're one person. You work with the same data, the same code, so on and so forth. That might make it easier. And then set up a GitHub account to synchronize code. Once you give us your username, we'll invite you to the org and create a repository for you. There's also a demo. We're also going to do some GitHub today, actually. So you're going to want to install Spark. So I'm going to ask everybody to do that now. I'm going to give you 10 to 15 minutes to install Spark on your EC2 instance. You're only going to need it on the team's master node, but if you have it on your own node, you can help prototype and experiment. So there's some directions. If you click on that blue link, you'll need to download the slides if you haven't done so, or you can go to this link here, https://github.com, Ryan Rosario, MSBA 405, sample pipeline. So I'll give you some time to do that, to go to the website. And let me actually switch to the browser here. Go back to the slides for a moment. There are optimizations you can make in Spark so that it uses less memory. I'm going to let you research those if you need them. Spark is not as fast as Pandas because what we're doing here is we're actually using Spark on non-parallelizable and non-distributed data. So it's actually going to be slower than Pandas. But the goal is to teach you how to use Spark so that when you're using a distributed system at work, you know how to use it. There's a tool called HTOP that you should always be monitoring when you're running a Spark job to make sure you don't run out of RAM. If you start running out of RAM, I'll show you that in a moment, you want to quit the Spark job before it crashes your entire instance. Now, there are times when you want to keep things running in the background, even after you disconnect from the server. So that's what I'm going to show you next, is how to do that. That's using a tool called tmux. So we'll switch to the terminal now. And the first thing you need to do is that you need to install it. So let me get a cleaner command line there. You're going to do sudo apt install tmux, like that. I thought it was already installed, but apparently it's not. Mm-hmm.
How to quit Spark?
How to what?
How to quit Spark?
Oh, Control D. To quit Spark, use Control D. And somebody over here asked, oh right, the project question. For the project proposal, one person submits the proposal. What you do is you add in the names of everybody else in your group on the submission. One submission. For the form, the Google form, one person submits the form. I mean, we'll just dedupe it. The plagiarism detector will actually catch that multiple people submitted the same URL, and then we'll know just to dedupe it. So you're going to do sudo apt install tmux. All right, now I'm going to show you a demo of tmux. So I'm already in tmux. Let's get out of this. Whoops. Oh, that's why. There we go. All right. I have too many windows open from doing this demo. So let's go back to home. All right. This is your basic command prompt that you're all familiar with now. To enter tmux, you type in tmux. Now, at the bottom of the screen, you get this green bar. If you have that green bar, it means you're in tmux. You are now you're in ultimate nirvana now. You can create as many windows as you want. So I'm going to have one window that's a command line where I simply run commands. Now I'm going to have another window where I'm going to look at some code. So here's how I do that. Listen very carefully because the keystrokes are not trivial. You're going to hold down Control, tap B, let go, and type C. Control, B, let go, C. So I'm going to create a new window. Control, B, let go, C. You have to do it quickly. All right, so Control B quickly and then C. Control B quickly, then C. So Control B, C. Control B, C. All right. Now at the bottom here, you're going to see how many windows you have. I have one window called Bash open. I'm going to create another one. Control B, C. Now I have two at the bottom. Now I'm going to open my code in this window. So I'm going to cd into Spark. Oh, right, I need to go, I have this in a messy place. Here. And now I'm going to load my file. Now I have my Python code in one window. Now I need to switch back to another window up here. This is important so I don't have to repeat it 5 million times. Now I want to switch back to my command line window. So I do Control B again, W. Now I select the window that I want, Bash. Now I'm back at my command line. Let's say now I want a window for, let's say I want to run PySpark here. So now I have two windows, PySpark, my code. Now I need a command prompt. So I do Control B, C. Control B, C. Now I have a command prompt. So I do Control B, W, and I have a command prompt, I have my code, and I have my Spark session. Now here's the beauty of this. If you get disconnected from your instance, You don't lose your work. So I'll show you that. I won't disconnect myself. But what you're gonna do is the next time you log into your instance, you get back the standard command prompt. You type tmux attach, and it attaches your windows. You haven't lost any work. Now, you will lose work if you reboot the instance though. You lose those windows. So to repeat again, if you get disconnected and when you log in again, you're gonna get a standard prompt. To attach to your existing windows, you just type tmux space attach and you get your windows back. So now you can run a long simulation and not worry about getting disconnected or losing work. We're gonna need this for the next part of the demo. And when are we supposed to take a break? So that's an hour and a half, 5:40. All right, we still have plenty of time. Okay, blah, blah, okay, I can hear it. All right, so now what are we doing next? So that's tmux. You should use tmux often. You don't have to, but you should use it. Yeah, so I told her she just has to try to shut it down. Try to start it again. If she doesn't have any data she wants to keep, just try to start it again. Yeah, that's gonna take a while though, because she has to go through the directions one more time. Make sure it's a Ubuntu instance though. Oh, you got it. Yeah. Yes, I gave him instructions. Okay, so some of you are trying to load PySpark. Some of you are trying to load PySpark and your instance is crashing. I don't know why that's happening, but I have an idea. You probably have Neo4j running from like lecture 4. What you need to do is you need to sudo system ctl stop Neo4j. Neo4j is a huge memory hog. And do the same thing with Postgres. So run this before you enter PySpark if you've been having issues with it crashing. This is why we need to get bigger instances. One database should not take down a whole instance. Okay, so as I mentioned, I will give you directions later on how to change the driver from Python to IPython. That's why I have this nice little number here. You have chevrons, so just arrows. Okay, so we did the demo of tmux. There's a cheat sheet that you can use that's in the slides that basically goes over what we just went through. You can also divide your screen into vertical panes or horizontal panes if you like that. There's another command if you want to scroll within the window. You need to use, I didn't put it in there, but you need to put Control B followed by the open bracket. So Control B, C creates a window. Control B, open bracket, lets you scroll through a window. Then you use the up and down arrows to scroll. All right. Okay. Now, one thing you may want to have running consistently within tmux is htop. So I'm going to create yet another window, Control B, C, and execute the command htop. My instance contains 4 gigs here because I needed to prepare. But you can see up here, you have a 0, these numbers 0 and 1. This is the load on the CPU. There's 2 CPUs. While you're running a Spark job, it might spike. That's normal. What you really want to watch though here is the mem bar chart. It tells you how much memory you're using out of how much memory is currently on the instance. So here I'm using 560 megs out of 3.82 gigs. If this bar turns red, abort what you're doing. You're about to crash. So then go back into your Spark job, hit Control C or Control D, and abort that job. Turning red is very, very bad. So that's where you just want to abort the job. So for some of you who are having this issue where PySpark is crashing, I want to look at your HTOP to see what the issue is with your memory before you run PySpark, because there's something running there that shouldn't be running. So that's HTOP. Next, we'll go into a data pipeline demo. So remember that this is the goal, this is your deliverable for this project, is to write a pipeline. That's one of the goals of this class. Yes?
When you say pipeline, you just mean taking basically something from the very start to the very end.
That's exactly what I'm about to get into, but you're absolutely right. So we go step by step from A to Z with minimal chaos. That's our goal. So we'll talk about that now. All right. So I unfortunately disappointed some people last section because apparently they're using this exact data set. That's fine. I'm only doing an example pipeline. So I took some data from New York City Taxi Commission. So it's data about taxi trips. You can download data from every month for all rides for every year. And the weather data from NOAA while it's still available. So what I did is I downloaded both data sets, and my fake analysis I want to do here is I want to look at how does taxi revenue, hourly taxi revenue, change based on the day of the week and based on the weather conditions. So are more people taking the taxi when it's raining or something? If you think about this, though, you got a subway, and people probably prefer to take the subway or something, but whatever. So you could do that analysis using these two data sets. So two disparate data sources joined together in order to do an analysis. So we're going to talk about how to create a pipeline and what that means. The pipeline is going to take the data, and it's going to produce enough data that we can then run a visualization on top of a bunch of aggregates. So this is what the pipeline, I forgot I drew anything here. This is what a pipeline looks like. Mathematically or computer sciencey, this is called a DAG, a directed acyclic graph. So it's a graph. There's no cycles here. We don't want cycles. We want to be able to predict. We start at A, we end at Z, without getting stuck anywhere in the middle in a loop. And it's directed. So data only flows in one direction. So first I start up here at the top with my 3 data files. That's what we have up here. So I want to know what these data files are in your proposal. I have taxi trips, which is a Parquet file. A Parquet file is a binary data frame. I save my data frame that I'm working on to a Parquet file. I open and load the Parquet file. I have a data frame. I don't need to process anything. I'm not processing CSV or anything else. It's binary. It's like a pickle. So you've used pickles, or at least you've told me, that you've used pickles in Python or the shelf library. Same thing. Then I have a lookup table called taxi zones. It's a CSV file. And the pickup location and the drop-off location are integers in the taxi file. But I want to know like which borough the drop-off and pickup were in and what part of the borough it's in, like, Broadway in Manhattan or something. Because maybe I want to plot this on a map in Tableau and have a nice visualization in Tableau. So I need that data. Finally, I have the weather station data. So this is from Central Park in New York City. Every hour, there is a observation recorded in the data set, about a bunch of stuff. Humidity, temperature, a sky cover, a bunch of stuff. Then, what do? We load, it's technically extract. We extract all of this data and import it into Spark. And in Spark, we're going to do a bunch of pre-processing, cleaning of the data. We're going to do projections, selections, renames, and joins. So what do I want to join here? I want to join the taxi data with the zone data, and I'm going to do that twice because I have pick up and drop off. And then I'm going to join that result with the weather data. And so I'm going to show you an analysis of how to do that in Spark. The Spark job is going to create a bunch of output. It could be CSV, but in this case, I want it to be Parquet because DuckDB can natively load Parquet in one slurp. So let's just use Parquet. Then we're going to load those Parquet files into DuckDB. Now, last hour, their group is using BigQuery in Google Cloud. That's fine. It's a data warehouse still. So DuckDB, if you stick with the spec, but as long as you use a data warehouse. So if Redshift is free, you can use that. If you want to get a student account with Snowflake, I don't know how that's going to work, but you may be able to do that as well instead of DuckDB. So we're going to talk about this part of the pipeline here. The visualization really isn't part of the pipeline. It just uses the data that's produced in the pipeline. So that's what we're going to talk about next. Are there any questions about what we are doing? This is what you are doing as well. And it's going to look very similar, except maybe you have 2 files instead of 3. Yeah.
Like the intermediate layer, like should you have a like production lead, something like that? Like if you're assuming it's like the actual product or like
Here,
yeah.
this is not the product.
So
This is the data from Spark.
So even for our project, it is okay to like just not needing a database between the intermediate layer, just directly loading data.
So you want to take the output of Spark and put it into a database,
Yeah.
and then from the database put it into DuckDB.
Yeah. So
You could do that. I mean, that's just extra work though.
so like, we don't need an extra database, but you can just directly load it to the DB. That's okay for.
Yeah, so I mean, it's more work though, because now you have to write from Spark into the database, and then you're going to have a SQL script or some kind of script that runs from the database into DuckDB. So it just adds another step. I mean, it's good to show complexity, but you might as well just use the intermediate files and load those. I don't know what the purpose of the database would be there.
Yeah.
You can do it, but I just don't know what the purpose is.
Yeah, I was just like validating, try to validate if it is okay for a product to like not have a database because.
So you don't want to have DuckDB at all.
No, like have a DuckDB.
You have DuckDB, okay.
Yeah, but not having like, for example, like RDS, like production DB, because that was because like we thought we learned that we need to separate like all TP process and all that.
Yeah.
We should do like directly for the analytics process from the pipeline data, which is repository.
Oh, I see. If you process your data enough though in Spark, you won't have that issue. You'll just be loading in an exploded table essentially. And then you can do all of your aggregates in DuckDB.
Oh,
So you can do it that way, but if you want to use the database, that's fine too. You can use RDS, I think up to 5 gigs or something for free. Make sure you look it up though before you do it so you don't get charged. Are there any other questions about this pipeline? Okay. I think it looks worse than it is actually, to be honest. So here's what we're gonna do. We have our data, we're gonna pre-process it in Spark. Then we're going to load the data into DuckDB based on the output that comes from Spark. Then we're going to connect the DuckDB from some kind of visualization platform. We may have to change the spec here. I'm going to try to cover Tableau next Monday. And I encourage you to read about it on your own. You get free access to it as a student. If it ends up being too much, we can do some other kind of visualization, a shiny dashboard. In the worst case, a static report. You generate a report in your pipeline with containing graphics. I'll give you more information later about that. Now, I'm going to show you how to create this pipeline in Bash, which you've learned a little bit about Bash. You'll have to learn more about the syntax on your own, but I'll show you an example of it. You can use Python, and there's a way to use Python to do this. The problem with Python, though, is that you have to manage all of the system calls yourself. So you have to call like sub-processes, and then pipe read the output of the command via a pipe into a variable. It's a mess. That's an operating system thing that the CS people can worry about. So Python can be a pain. All right, so let's go through that demo. I'm gonna start with the Spark layer. Now, you can follow along here. And the way that I suggest following along is by downloading doing a variety of things. So let's get into that. So final taxi MSBA, great. So this is the root of the GitHub repository. You're going to see here that I have a README file in the root of the repository. It's easier to read it in the browser than it is in here. So let's look at that. To clone this repository so that you have the same data that I have. So, maybe go to your home directory and you're going to type git clone https://github.com/myname/MSBA405-sample-pipeline. Like that. It's also written up here. And then you're going to hit enter. If you get an error that the command does not exist, you need to install git. So how do you do that? You do sudo apt install git. I think it's just install git. I don't know if it's git core or just git. Let's try it. Yeah, it is just git. When you hit enter, you should not get any errors. Let me actually do this with you. I'll do this in a temporary directory. So I hit enter. Here's the result I should get. It says cloning into, blah, resolving deltas and all kinds of stuff. Once you've executed the command, type in ls. Ooh. You should get a directory called MSBA 405 sample pipeline, like that. Okay. We're going to do one more step, and then we'll take a break, and then we can give you help. Did you figure it out? She did? Okay, cool. All right, we'll do one more step, and then we'll take a break for 15 minutes. All right, now we have our data. CD into the repository. So ignore the fact that I'm in TMP, the TMP directory. Ignore it. You're going to CD into the repository like this. And let's take a look at it. I have a few directories here: Airflow, Bash, Data, DuckDB, Luigi, Spark, and a README file. Now you're going to CD into the data directory and hit enter. If you do an ls, I don't think there should be anything there. In mine there is, but I don't think there is in yours. There might be a hello file, but what is there? Okay, just leave it there. Or delete it, I don't care. Okay, now what do? Now you're going to download the data. So you can do this one of two ways. You can open the README file in another window, or you can go to the website. What? I'm hearing things. I thought somebody said professor. So again, these are the files. And I paste it. Now I already have this file in here. Should I delete it? It's actually blank. I'm in my temporary directory. All right, fine. I just copy and paste it, the wget command, and I hit enter. It downloads the taxi data. Now I do the same thing for the other two files as well. Now that's downloaded. Now, finally, I wget. I need to fix this README. So I type in wget, and I copy and paste that final URL for the weather data, and I hit enter. Now this data contains New York City weather conditions for every hour of every day in the year 2024. So it takes a while to download. Okay, so if I do an ls in my data directory now, in addition to the hello file, I should have a numbered file, which is the weather conditions, a taxi zone lookup file, which I use to look up location IDs, and I have my original taxi trip data. And now I present to you a demo. Before we do the demo though, let me get out of this so I don't actually share the wrong tab here. Before we do the demo, I want to show an error that I made, and I want to show you this on purpose to show you how to use Git. So let's, we're in the terminal already. So the error was here. It's in the README file. I don't know if I saved it. Okay, I didn't save it. The error is here. This line shouldn't have a wget in front of it. All it is a source of where I got the data. So let's get rid, but you have this error. So we're gonna get rid of the wget here, and I've added a wget down here, which wasn't there before. So I've made a change to this repository. Now I wanna share that change with you. And the best way to do that is by using Git. So what I'm gonna do here is I'm gonna do a git add on the file that I want to commit. There may be multiple files. If there are, I just add them. I don't use a comma, I just keep adding files. So if I had a file hello, I would just do that. So git add readme.md. Now it's staged for commit. Now I'm gonna actually open a commit. The commit lives locally though, it doesn't actually live on the Git server itself. So we'll run git commit, and I'm gonna write a little commit message, fixing bug in readme.md. And then I'm gonna write out and exit. Now I have a commit. It says I have one file changed. There were 2 insertions and 2 deletions. I don't know what the deletions were, but I'll make sure I double check that later. Now I've committed, but I'm not done. I now need to push this change to GitHub so that you can read it. So I'm gonna do a git push. Now it is on GitHub. If you go on to GitHub now, okay, it looks like I already have this file open somewhere. Here it is. And then do I have PySpark open? I do. All right, great. Here we go. The first thing I want you to do is I want you to copy and paste the import lines to make sure your Spark installation isn't screwed up. So we're gonna copy that. We're gonna go into PySpark and run it. You should not get any errors. If you get errors, this means you probably tried to pip install Spark instead of following the proper process. Okay, if there's no errors, which is good, we'll continue. The first thing we'll do is we'll create the Spark session here. So typically, you do this interactively. You don't copy and paste like this. You know, you just type into the code as you go. But I already have this written because trying to do a demo, making everything up on the fly is no bueno. You can type clear if you use IPython. Okay, so we created the session. Now what we're going to do is run this really long pipeline. Now we have pipelines, and we have Spark. We have ETL pipelines, and we have Spark pipelines. Because Spark can be used for ETL, and we are kind of doing that, except our load is just to the file system. I'm going to load my taxi data. So I specified that my Parquet file apparently has a header. This actually doesn't need to be here. We can get rid of that. This option here is supposed to help you save RAM. Basically what it does is it reads 128 megabytes of data at a time rather than the entire file. I haven't been able to get it to work, but maybe you'll have better luck than me. Then I specify Parquet and the path to the file. I'm currently executing this in the Spark subdirectory. My data is a cousin directory. I have to go up, over to data, and down to fetch it. So I do a /data/yellow trip data. Then all I do for now is project the columns that I want to keep, because there's a bunch of other columns I don't want. So that's what the COL does. It turns a string into a column reference. I'm going to keep vendor ID, passenger count, the number of people that were in the car, fare amount, and total amount. So total amount is the fare plus taxes plus fees. So there's an airport fee, for example. Now a couple other of these just have really ugly names, like TPEP pickup date time. I don't know what the hell that means. So I rename it by using .alias, pickup date time. Cool. So I've read in the file, I've removed some columns. What do I do next? Now, this is where your data chops are going to come into play here. You are going to find bad data in your data set, and you're expected to fix it. This data set, even though it's for October 2024, for some reason, there are dates that are in 2026. So they haven't happened yet. That's clearly an error. I want to filter those out. So I use the filter operator, which is basically a where or a selection. And I'm going to take the year from the pickup date time column and check that it's equal to 2024. And I'm going to do the same for the drop-off date time. Now this F here was imported. There's a series of data analysis functions that come with PySpark, and I imported them into a variable called F. So f.year is just a function that comes with PySpark. Then, what on earth is this? You're going to get into a lot of trouble and possibly crash your instance if you don't write your joins correctly, if you write a cross join by accident. So and I did this as well. It's writing joins is not as trivial as it is, well, I shouldn't say trivial, but I mean trivial for me, I guess. It's not as trivial as writing them in a relational database system. It's a lot more challenging. So what I do here is I add a sequence number to my original data. After I've joined all of the data together, this join should be one-to-one across the board. I have a taxi ride, I have the zones that the taxi ride started and ended in, and I have the weather condition for that hour. So it's a one-to-one join, basically. So in my result, I should have every sequence number appear exactly once. I should not have any duplicates. If I do have duplicates, that means there's something wrong with my join. So I would recommend doing this when you're doing a join. Duplicates means there's something wrong in your join. Your join condition is not strong enough, or you're not writing it properly. That's what this monotonically increasing ID means. It just assigns a number. Then I create a new column using the with column operator called pickup hour, and it's going to take the hour out of pickup date time and return it into this new column. So I'm going to get, I think this is going to give me a date with an hour. So it's going to give me, January 10th, 2024, 8 a.m. But it won't give me minutes and seconds. Let's run this. Now, you don't have to write it like the way I did. This is written like a pipeline. You can do individual steps like you would in standard Python programming. This is easier for me to understand, though, quite frankly. So now we'll switch over to PySpark. Now, I'm not done with the pipeline, so I come over and, or am I done with it? I am missing, the open quote, or the open parenthesis. So I close that. Oh, path not found, data, where am I running this? Oh, that's why. Okay, let's just exit out of this then and go into the right directory. So final, taxi, MSBA, Spark. All right, and let's try this again. So I'll have to run my imports again. Fun. I'm in the pipeline. So I need this. Okay. Then we will do our pipeline. So this is the pickup hour that I need to copy and paste over. And I still have, then I just need the close brace. Okay. Okay, let's see what we got now. So I did a bunch of filtering and a bunch of projection. I can do rides. So if I just do this, rides, this doesn't tell me anything. It tells me I have a data frame object. Why? Remember, Spark is lazily evaluated. None of it's actually executed yet. To execute it, I have to call an action. One such action is head. So let's look at the first 15 rows of this data frame. This is actually going to execute the pipeline, which is actually pretty fast. Unfortunately, the text is too big here. But what you would see here is that you get individual rows. So this is a row here. That contains pickup time, vendor ID, drop-off date time, passenger count. There's one person in the car. The fare, it was an $18.40 fare. And how many people were in the car? There was one person in the car. Okay. You can also do show, which will show you more than 15 rows, but it only goes up to like 20. So you'd have to pass a configuration variable to change that, and you can do that on your own if you want. Okay, what's next? Now what we're going to do is we're going to describe the fact. So we're going to give a fully functional data set here. Now we're going to join the rides data with the zone data. So we have a location ID for the pickup and a location ID for the drop-off, but they're just integers. Now we're going to turn them into names. Broadway in Manhattan, Central Park in Manhattan, Flushing, Queens, whatever. That's what this one does here. So I'm going to take my original data frame rides and join it to the zones data frame. Now, what does the broadcast function do here? This isn't really important on a single node, but if you're working on a cluster, the broadcast function takes a small table, like the zones table, and replicates it to each node in the cluster. This is actually a lot faster because a small data frame is now in RAM. If for some reason we need to read data from disk, we don't want to do it for both data frames, only one of them. Now it's very easy efficient to execute a join because one of the data frames is in RAM. So I'm going to do that join here. I'm going to join with zones. And if I get any name clashes because of the join, I'm going to add pickup to the column name. My join condition is rides.pickup location, which is an ID. It's not location ID, I take that back, but it is an integer, equals column pickup.location ID. So remember, pickups comes from the zone table. I should probably name that something differently. Then I'm going to join again because that was only for the pickups. Now I join again for the drop-offs, and if I have conflicts in the columns, I just add drop-off to the beginning, and I have the same join condition. So I've joined twice, simple inner join, inner equijoin. Then I'm going to project out more columns. I have my sequence number that's going to sanity check the result of my join, a bunch of other stuff. And I'm going to rename some columns here. So as a result of the join, I get some ugly column names. I get pickup borough, pickup zone, drop-off borough, and drop-off zone. So I'm going to call .alias in order to rename those columns something nicer. Pickup borough, pickup zone, drop-off borough, and drop-off zone. So let's see what that does. I just told you what it does, but let's see that it works and have our minds blown. So zones, okay, I didn't load the file. So let's do that here. So it's a CSV file, so I do spark.read.csv. I give it the path to my file, and I specify that it has a header. So we're going to load that. Now in IPython, all I need to do is hit the up key, and it actually remembers this entire block of code, not just the previous line. So we'll just execute that. Wow, that was really, really fast, but it didn't actually do anything. In order to do something, I need to call an action. So let's look at the first 10 rows of my new improved rides table. You now see that I have additional information. I have a pickup borough Manhattan, a pickup zone Midtown East, a drop-off borough Queens, and this is a Longity, Hunters Point, something like, oh, maybe Long Island, something, Hunters Point, whatever. Anybody from New York? All right. Yeah? Awesome. I love New York City. If my family wasn't here, I might move there. Or Amsterdam, or the country of Scotland. So now we have our rides data. Now what we're going to do is we're going to load our weather data. Now this part of the pipeline is a lot more complex because this data is very messy. The first thing I'm going to do is I'm going to read in the CSV file containing the weather information. I'm going to create a new column using with column that basically extracts the hour, so the date and the hour, but not the minutes and seconds, into a column called hour. So January 2nd, 2024, 8 a.m., basically. So that's what I have, a 2 timestamp and the date trunk for that. Now, in the weather data, this weather data is for all of 2024. I only want October. So I execute a filter here, a where. So I filter, I take the year of hour, make sure it's 2024, and I make sure that the month of hour is 10, so October. Then I project out the weather conditions that I'm interested in. I'm interested in the hour, the precipitation amount, the humidity, the temperature, and the actual weather type. So cloudy, rainy, snow, hazy, whatever. Now, the problem with this column is that it's very messy. It looks like this. So in 1 hour, I can have multiple conditions. At the beginning of the hour, it was raining, then it was sunny, then it was hazy. This is how it's represented. The plus means severe. Heavy rain, snowing, light haze. I don't need to deal with this for my analysis or for this class. So I'm just going to split on the pipe and take the first element. So the first condition is what I'm going to consider here. So to do that, I do this check. I create a new column called weather code first that splits hourly present weather type on the pipe and takes the first entry. Okay. Next, what do? Then I look at the severity, or I'm going to create a column called severity. I want 2 separate columns. I want the weather condition and the severity in separate columns. So I'm going to use with column to create a severity column. I'm going to say when so if there's no weather condition, there's no severity either. If the weather condition contains a minus though, I'm going to put light into the severity. If it's plus, I'm going to put heavy into the severity column. Otherwise, I'm just going to put moderate in there. So light, heavy, or moderate, but if there's no condition at all, put null. It's basically a case statement. Then, for some reason, there's a little bit of extra gobbledygook in this column. To be honest, I don't remember exactly what this does, but it matches a regular expression, and it removes this bad part. Next, I clean up the precipitation data. Sometimes the precipitation data has a T in it, which means trace. I don't care. I'm just going to replace it with 0. That's an assumption I'm going to make. So I have basically another case statement. With column precipitation, when hourly precipitation is T, replace it with 0. Otherwise, there's another case here, again, that's messy. Sometimes the precipitation amount looks like this, 1.25 S. I don't know what that means. It might mean scattered or showery. We're just going to get rid of the S. So that's what this regular expression replace does. It replaces an S at the end of the column with nothing, deletes it, and then casts the column to float. Then, unfortunately, the data is still messy. I sometimes have multiple observations per hour for whatever reason. I only want one of them. If I leave all of them in there, I'm going to end up with a little bit of a cross join, which is going to blow up the data. So what do? I use a window function to create a new column called rownum that simply computes a sequence number within each hour to each observation. So if there's 5 observations in an hour, I get sequence numbers 1, 2, 3, 4, 5. But I would hope that I only get a 1 for each hour. And then what do? I filter on row number equals 1. This makes sure that I only have 1 observation per hour. Once I've done all of that, then I project my columns. I take hour, precipitation. I'm going to change hourly relative humidity to humidity and convert it to a float. I'm going to change this blah blah to temperature. So dry bulb temperature is the temperature. I'm then going to project out my new column severity and condition. So let's now run this mega pipeline for weather. Now you're going to have to do this as well because your data is probably going to be messy as well. That's part of the job. So let's run this. Great. Go back to Nano. We did this next one here. Go back to nano, then we're gonna do these next two. So usually you would be using a text file to manage this. This is a demo, so I'm just copying it from here so you can actually see what I'm doing. All right. Wow, that was really, really fast. But again, it didn't actually do anything, and it's pretty fast anyway because it's just a transformation. So my weather table looks like this. It's going to run the pipeline now. You see a progress bar there. I have some times, precipitation amount, humidity 78%, 61 degrees, and there's no condition recorded. For some reason, most of these conditions are null. Okay, now, what are we going to do? We're going to take the rides data and we're going to join it with the weather data. So what do we do there? Well, we take rides, we join weather, and we specify our join condition. Our join key here is the pickup hour. So in both data frames, I have the same join key, basically. I have an hour with the date and an hour with the date. I can now join them. Rides.pickupHour equals weather.hour. After I do the join, I'm projecting out a bunch of columns that I want to keep. So let's look at that. Okay, again, join, but it was immediate. We need to run ahead or just do something in order to process this pipeline. Let's run count. Let's just count how many rows there are. That's an action, so it's going to execute the DAG, and I get back that there are about 3.8 million rows. So, or I can do a head, and I see now that I have my taxi information and I have my weather information in the same table, same data frame. Now we're done. Now we need to write this data somewhere. So we're going to use overwrite mode. This is optional, but what happens if you leave the output directory there? You're going to constantly get errors. You need that the output already exists. So you need to delete the output directory. Overwrite just takes care of that for you. And then I specify parquet. I want to write all these files up a directory in the output directory as parquet files. Here, this is for parallelism. I don't know if it helps here, but basically I'm saying I want 100,000 records per file maximum. So it's going to divide these records into a bunch of different parquet files. So let's run that. So this is stage 26. Now this is the number of tasks that are completed, 0. This is the number that we have yet to execute. And the last one, the denominator, is the total number of tasks. So you see that I had 2 tasks. That's because I have 2 cores on this machine. So now my data is written. So now I can cat output. Well, I actually can't because it's binary data. But you're going to have the success flag, which is empty, but it's a file that basically denotes that your job completed successfully, and it's used for downstream processes. So that gives you an idea of my thinking and how to write a Spark job in order to do analysis. Are there any questions about Spark? Now, remember on your homework, exploration and interactivity is done differently than executing a Python file through Spark Submit. You have to add a couple things in order to get it to run in Spark Submit. Okay, so now what we're going to do is we're going to look at the Bash pipeline for this. Actually, no, we're not. We're going to look at the DuckDB part of this. Now, I have my Parquet files. I can read those Parquet files natively by doing a create table if not exists. The if not exists is important here. If I run my pipeline multiple times and the table exists, it's going to fail. So I'm going to read the Parquet files into this table, and it's going to infer the schema. Now this load path is going to be substituted in the Bash pipeline. All it does is it plops in where to read the Parquet files from. You can hard code it if you want, that's fine. I do a couple of transformations to change data types, and then I create some views. So a view is like a temporary table. Tableau or whatever visualization thing you use is going to use the view, not the table. The view contains our analyses. So here I have my grouping columns, which are going to be the times of the day. So year, month, day, hour, and minute. I'm then going to compute like the total number of, the count number of rides, the average passenger count, trip distance, fare amount, the sum fare amount and total amount and whatnot. So things that I might want to aggregate, so measures that I want to aggregate. Then I'm going to group by a roll up. So I want to do this hierarchically. So when somebody clicks on a year, they then see the aggregates for the month, and then can see the aggregates for the day, and so on and so forth, down to the minute. Then Tableau just needs to read this view. It doesn't need to compute anything. It's fast, very fast. Next. Now I want to do an analysis by the day of the week and the hour, because there's a lot of periodicity here. Monday mornings are going to be heavy because people are going to work. Friday evenings are going to be heavy because people are leaving work. And hopefully they leave work on the other days as well. So we have measures by DOW. Again, I have my same measures here, but now I'm going to extract the hour and the day of the week. So Sunday, Monday, Tuesday, so on and so forth. This time, though, I'm going to group by grouping sets. I no longer have a hierarchy here. I have day of week and hour. There's no hierarchy there. So I'm going to have an aggregate for each day of week and hour. I'm going to have an aggregate for each day of the week. And I'm going to have an aggregate for each hour of the day separately. That's what grouping sets does. If I did group by cube here, it would pick all subsets of these two columns, Dow and hour, which is going to give us a lot of nonsense. Then finally, I create a view with respect to weather conditions. So now I have, my pickup day and time, my condition and severity, the same measures, and I group by grouping sets again. So, I have different pairings that I want, but I don't want all pairings in triplets. And then I order by the day, hour, condition, and severity. So let me actually see if one of these is, let's do this one. Let's execute this one in DuckDB. Actually, I'll just do it here since I'm in the proper directory already. So do I have my, yeah, I do. So I do DuckDB quack final.db, and I paste in my query. That created the view. Now I can run a select star against it, or you know what? We're just going to do from measures by Dow. See if that works. It doesn't. So let's do it. Let's just stick with what we know. Select star. Oh, it's because I got the table name wrong. Let's try measures by Dow. And it's kind of hard to see here, but you get back a nice table basically showing the data that's in the view. And this is now accessible to Tableau. Okay, so now we've seen DuckDB. Now we're going to look at Bash. So we're going to cd into Bash, and I have pipeline.sh, pipeline.sh. And we're going to take a look at that. This is the glue that runs the entire pipeline. Now, I try to follow best software engineering practices here to the point that this is annoying to look at. Basically, I want to make sure that I use variables so that if I change anything, I change it in one place, not in a bunch of different places. You can hard code stuff if you want. So I specify the DuckDB executable, the Spark executable, the path to my Spark job, the path to my database, the output, where my queries live, the taxi data, the zone data, and the weather data, blah, as well as where I should load the Parquet files into DuckDB. All right. Now, one of the purposes of a pipeline is atomicity, meaning if I run this pipeline and it fails in the middle, I do not get crappy data, inconsistent data. It'll actually roll back and delete that inconsistent data. So I'm back in the same condition that I was in before I ran the pipeline. That's what this rollback function does. If anything fails, I'm going to delete the Spark output and I'm going to delete the DuckDB database. Okay, then I have a little function that prints a message given the message. Now this is important here. How do you check if something executed successfully? You look at this little variable here. So you're gonna have to look into Bash syntax here. This little variable, $? contains the exit code of the most recently executed command. Every command returns an exit code. 0 means successful. Anything other than that means failure. So I'm checking here that the exit code is equal to 0. If that's the case, then I'm going to pass the success message, whatever that is. So when I call this check function, I'm going to pass it a success message and a failure message. So I'm going to send the success message here. Or otherwise, if we fail, I send the failure message, and then I call the rollback function to delete my inconsistent data. Finally, I exit 1. The pipeline has failed. I exit with a return or exit code of 1, not 0. All right, now we're actually getting into our operators here. I have a run Spark operator or function here. The first thing that I do is I preemptively delete the output directory so I don't have to worry about getting an error if the directory already exists. Then I call Spark submit, the executable, which is in this variable $Spark. This is basically Spark submit. Then I pass some configuration parameters. This first one, master, local, means that I'm running on one node. It means do not use the Yarn cluster manager. We're running on one node. Then I'm passing a couple of other configuration parameters. This is my attempt to not overload the CPU, saying I only want to shuffle 2 partitions at a time because I have 2 cores. I think you can get away with not including this, but if it crashes, you have this and you can just copy it into your code. I give a name to the job for the UI. Then I specify my Python file containing my job. Transformer is basically a Python file. I pass it the path to each of my data files, as well as the output directory. Now, I then check the output of this command. If the exit is 0, meaning it's okay, I'm going to send the message Spark job completed successfully. Otherwise, Spark job failed, and the entire pipeline just stops. Now the data is now in a directory. Now I run the run duckdb operator. The first thing that I'm going to do, that's what the stream editor command does. That's why we taught it or implied. I talked a little bit about it. I'm going to take that load data token that I had in the query SQL file and replace it with the load path variable that I coded in earlier, which is just output/star.parquet. So you can hard code that if you want. It converts that SQL query, set of SQL queries with a proper path, and then it pipes the result of that into DuckDB. So this is the DuckDB executable with a particular database name. Then it's going to check, was it successful? If so, data loaded into DuckDB successfully. Otherwise, data load failed. Now we're in our main function down here, basically. I print a message, starting sample pipeline. I run the Spark operator, I then run the DuckDB operator. And then finally, if it finishes correctly, I print process complete. Otherwise, pipeline failed. It's a fairly simple script if you ignore all the environment variables that I set here. So let's actually run this pipeline and see what we get. So just in case, I don't think I need to delete anything. Let's try it though. Yeah, so we're gonna run bash pipeline dash. Let's see what happens. Starting sample pipeline. Now you can run this pipeline because you have the data. Now it's actually executing the Spark job. It gives you a lot of output, even more so than in interactive mode. Okay. The DuckDB part is very, very fast. So the Spark job completed successfully. The data was loaded into DuckDB successfully. Process complete. That's the entire pipeline. This is what we want. You write a file, you write a script, you run this script, your pipeline's done. We don't have to do anything manual to check anything. That's a point deduction if you do. One file executes everything. Now I want to show you something. I want to show you the job tracker for Spark. In order to do that, though, I have to have a running job. So I'm going to run this pipeline again. Okay, right. So some of you brought up a good point. Can we use S3 basically as a middle storage layer? That's not a bad idea. There's a couple things you might be able to do here. You might be able to build your own Spark cluster. It's actually not that challenging to do if you have some technical skills. And you can group together your 6 EC2 instances into a Spark cluster and share the gigabyte of RAM you each have. You're not going to get much of a benefit because that's only going to be 6 gigs max, but you can do that. Another thing you can do is you can run Spark on one node and run DuckDB on another node. So you separate the load, but you're going to have to use something in the middle in order to store your data. And that could be either a database or S3. Probably S3 is better, but be careful with S3 because you get charged for that if you go over a certain amount of data, and it has to be within region or you get charged for that too, which is why I'm not doing AWS again. What else was there? Yeah, so that's that. Some other people are doing things like with Docker and whatnot, and they're executing a Docker job on AWS that will run some kind of workflow processing. You can do that too. That's great. That's why I hope you do. But we're all at different levels, so we don't have to. So now we're going to talk about do a little bit of a demo in our last 20 minutes of Luigi. So as I mentioned, we saw an example of a Bash script to run a pipeline, and that's perfectly fine. You can do that. There's nothing wrong with it. But I mentioned that it's difficult to do this in Python because you got to manage all of these sub-processes and check for exit codes and all this kind of stuff that we don't have to really do in Bash, or it's easier to do in Bash. But you can still use Python. And the way you do that is with something like Luigi or Airflow. So let's actually take a look at that. I won't be able to walk quickly through the code, and you can learn more if you want, but you have Luigi in the GitHub repo if you want to play with it. So again, there's a link for GitHub. Luigi is not named after this guy. It's this guy though is actually a data scientist and a software engineer. It's named after this guy, Luigi from Super Mario Brothers, because they were plumbers in the original storyline, and we're building pipelines here. Yeah. So don't end up with a shitty pipeline, or we're gonna have Super Mario Brothers coming to try to plunge it out. So that's Luigi for you, and Mario and Luigi. It's a me, a Mario. So the logo here is a bunch of pipes, basically, because of that. So it's a Python package, simple Python package, doesn't need much infrastructure. It lets you build complex pipelines. It lets you handle dependency resolution, which Bash is very simple with that. Workflow management, visualization, handling failures, and all kinds of things. It was developed by Spotify, and you can install it with a simple pip install. Now, unfortunately, these days, installing packages on Python is a pain, especially on Ubuntu. You have to create a virtual environment, which I hope you learned about, but you need to do that if you want to use this. And you're going to have to run this command. Actually, I'll write it on here since you have the slides up. You're going to have to install virtual environment. So it's sudo apt install python 3 -venv. So you need that first. And every Luigi pipeline contains two things: tasks and targets. The tasks are what's actually being executed. The target is what the task produces. So the next task in the pipeline is going to use the result of the target in order to complete its work. This is similar to a makefile. If you've ever done programming with makefiles, it's the same thing. You have tasks and you have targets. Now, each task, though, has three components: a requires component, a run component, and an output component. The require specifies the prerequisites. This other task must have executed successfully, or these files exist. The run specifies what you're actually running in the task, and the output defines the output of that task and what we do with it. Then, once you've written your pipeline, all you do is you execute Python pipeline and run it. So let's do a little bit of a demo of that. All right, so we're going to go into Luigi, and I'm going to activate, how do I do that? It's source Luigi, because it's in another directory here. Bin activate. All right, now I'm in the Luigi virtual environment, which is required because that's where I installed the Luigi package. So now, what am I going to do? I'm going to show you the pipeline. It's written as a standard Python program. So it uses object-oriented Python though, so classes. So here, my first task is an input file task. I want to make sure that the file exists, whatever it is. So I have 3 of those, maybe even more in my pipeline. Then I have my Spark job task, which is actually a special operator called Spark submit task. I have all of my directories and files up here. I specify that I require the taxi, zone, and weather data. If I don't have those data sets, the pipeline or task task fails. My output is going to be a success flag. It's going to create a little file called OK Luigi in the output directory, which signals to other processes that the Spark operator completed successfully. This complete function isn't always necessary, but what it's doing is it's double checking once the task runs that we did actually create that file. Then I have some app options for Spark, and then I have the run statement here, which basically runs Spark. It creates a command, and then it runs Spark. This doesn't do anything fancy. It's actually just running it through Bash, which is not the greatest example, but it works. And then we're going to create the Luigi file here once we're done. So that's a Spark task. The load duckdb task is similar. It has a requirement. The requirement is that Spark job task is executed successfully. So it's going to check for the OK Luigi file. The output is going to be another success flag. So it's another file. I don't remember what it's called, but it creates a little empty file that signifies that the DuckDB database has been properly filled. And then the run statement does the following. There's a lot of logging in here. First, it's going to load the database file or create it if it doesn't exist. It's going to load the SQL file as well. It's going to replace that load path token with the variable that I've set here that specifies the output with that wildcard. It's then going to connect to DuckDB using the DuckDB Python package, execute the script, and close the connection. Then finally, it creates the little success flag. And that's it. There's also the main function simply creates the pipeline essentially. So I don't know if you've learned this, but the proper way to write a Python script is you have a main function and then you use this guard here. If name equals main, run the main function essentially. All right, so let's watch it work. Okay, it's executing the Spark job again. So lots of output when you run in this mode. Come on. Okay, now it's waiting 5 seconds to make sure that OK Luigi file is created in case there's a race condition. And then the DuckDB step was very, very quick. So you see I have 2 tasks run successfully, DuckDB and Spark, and that's it. That's the end of my execution. Now I want to show you something else you can do here. I hope it's still running. I'll try it. If you punch a hole in port 8082 and run this pipeline again, I may or may not create a demo of Airflow. It's a little finicky and there's not a whole lot interesting to show because it's all back end. You don't even know what the pipeline's running. I don't execute a script or anything. It just runs in the background. So it's not the most exciting thing, but it is still pretty cool. So Airflow is very popular. Some people say it's a little out of date. I don't know. I think it's still useful. It includes a lot of additional features like scheduling, monitoring, and alerting. So it can send you an email when a job fails or succeeds. One thing you're going to get used to when you work in industry is you're going to get a million emails a day. Most of them are meaningless. They're status emails. This pipeline failed. This pipeline succeeded. You're running out of space on this node. I don't care. I'm a data scientist. I don't care. But you're still going to get those emails. Now, I have a connection to the creator of this thing, Maxime Beauchemin. He worked at Facebook about the same time I did. We overlapped for about a year. And he used to come to all of our team happy hours. Facebook was a bit of a frat house back then. And there was, a lot of happy hours. Every team had their own bar. There was lots of alcohol. There was lots of shenanigans, including at the yearly holiday party. And, the behavior may have changed now, but I'm curious if the bars are still there. So this guy would come to our happy hour every week, and he was good friends with a lot of the data engineers that worked on our team. He left Facebook and he went to Airbnb and created Airflow. It was inspired by Data Swarm, which is another similar package that was created by Facebook, or should say Meta. It's written in Python, but it uses SQLite to coordinate metadata, which is kind of interesting. So Luigi does create a DAG. It does create that graph that I was talking about, but it's not as explicit. You're really creating the links between the components of the chain, really. You're creating the task and what comes next, but nothing else. In Airflow, though, you're specifically creating this graph of tasks that are executed. So, if this graph is Airflow, a Luigi task is C and E, basically. So it's very modular, more modular in that regard. I misspelled data engineers, okay. It's a lot more complex, it's more scalable, it's a lot more powerful than Luigi or a Bash script. But process progress really isn't transparent to you. You have to log into a web server in order to see a bunch of stuff, and it's not even easy for me to figure out what's going on. So it's a very busy UI. So we have about 5 minutes. That's not going to be enough time to do a demo. What I will do is I may record a demo of this just to show it to you and how it works. Was anybody thinking of using Airflow for their project? Maybe I'll change your mind, but yeah. So if you don't have to use it. You can use Luigi. You can use a Bash script. I don't care. You can use AWS's offerings as well, which is probably easier as long as you're willing to learn it and as long as you're not being billed for it. All right. So that's all I have. I think that we'll stop here for today. Remember that the proposal's due tonight. Try not to stress out too much about it. I will skim them tomorrow and leave you feedback. For now, you should assume that you're good to go and keep working. Don't stop and wait for me. If anything, we just add another data set for you to play with. That's it. And we'll fill in the gaps. We want to make sure that you're thinking about everything properly and that you can finish this project. We will make a decision about what to do with the visualization layer. We may use Tableau, we may not. Some people may want to use it, others may not. It depends on how much time we have left. It doesn't seem like it was an issue last year, but we'll see how it goes. And let's see, the homework 4, I don't remember when it's due, but that'll give you practice with Spark. And if there's any questions about the exam, let me know. There's no regrade thing because it's not on grade scope. But if there's questions about things, I can take a look at my answer key because I don't remember. It's been a while now. Okay, so that's all I have for today. Thank you, everybody. This went much smoother than last section, so thank you for that. And I apologize if you have friends in that section. Apologize on my behalf. I hate it when that happens. But I think that this type of demo type thing is kind of what we were going for in this class. So hopefully in the future we can do more of this, depending on what we end up doing with the content. I want it to be modern. I want it to be useful, and I don't want to leave people behind here. So thank you. Have a great evening, and we'll see you next week. We'll be in touch in the meantime. somehow.